Good evening, everyone. There's a mysterious red object in the skies tonight. And I am, of course, here to investigate that with you. It is none other than the planet Mars. Welcome, everyone. This is Professor Elena Hyde from the Allan I Carswell Observatory at York University. We are broadcasting live this evening. And we are very pleased to announce that there are, in fact, not clouds blocking our view. So we'll be able to talk all about this very interesting red star. Not a star, it is, in fact, a planet. So the planet Mars in opposition being very, very bright in the sky. I am joined this evening by Obada, Anna, Kat, Quinton, and Sunna. And we are here from the Allan I Carswell Observatory with our live Mars opposition event. This event will be running over several days here in October. We are going to try to run all the way through to the 15th if we can, of course, weather allowing. So tonight is our first real clear night on Mars viewing. And so we're going to start off with a couple of fun facts about Mars while we play and point with our telescope. We're also going to maybe try to hop by Jupiter and Saturn on our way. But this is a little getting started here. Just so you know, this is a spin-off program from our regular York University Allan I Carswell TeleTube broadcasts, which are every Wednesday night here on this same channel from 7:30 p.m. local Toronto time. So if you want to hear about more than just Mars, make sure to come back on one of those Wednesdays. Our YouTube production works in concert with our Monday night observing online public viewing, as well as our York Universe radio show. If you have any questions or comments about past shows or suggestions, you can, of course, chat with us live here. And you can also email us at observe@yorku.ca. And if you're following along on Twitter or Instagram, that's at York Observatory. So I am very, very pleased to be able to get started here with a bit of a bang, as it were. We do have Mars in the sky right now, as well as a bunch of fun things to tell you about our red neighbor. So this is the Mars opposition event. And we will be talking a little bit about what opposition is and, why are we looking at Mars, as well as some of the fun things we're going to try to see on the planet with opposition happening. So let me just go ahead and actually very just quickly show you a little picture about why are we so excited about Mars opposition. So some people are wondering, so this is not live from our telescope, but I'm just going to go ahead and put this picture up now. This is an astronomy picture of the day. And this is why people get very, very excited when Mars is in opposition. It's because it is much easier to see. It's not only brighter in the sky, but you can see so much more detail from the surface of Mars. And especially features, you can see that there are these bright and dark features. Those are albedo regions. And this opposition in particular, Mars has really increased in brightness substantially. So this is they call it a visible magnitude of negative 2.5 to 2.7. This means that right now, Mars is brighter than Jupiter. Mars is brighter than the star Sirius. So if you are looking outside right now towards the east, you will see a bright red object up on the sky. You might notice that it is in fact not twinkling. One of the first things we always like to point people to about planets versus stars in the sky is that planets don't actually twinkle. So you can usually tell if it's a planet or a star by how twinkly or shiny, fluctuating that light looks. So the light from planets only travels, a few millions of kilometers instead of many, many light years, much like we have for stars. So if you are looking towards the east at the moment in Toronto, you will see that bright red object in the sky. That is the planet Mars. If you like to track your constellations, this will be somewhat near to constellation Pisces at the moment. Alrighty, so welcome everybody. We have all kinds of great, great things planned for tonight, of course. And we have a great crew tonight here to run with us through all kinds of fun Mars facts and all kinds of great stuff. But before we get too into different kinds of explanations, let me just hop over to our live telescope view and see how we're doing with the planet Jupiter. So it's always a little bit of a gamble whenever you try to do live views. So just a moment here. Okay, so as you can see, just coming into the picture now, we are showing you the images through the eyepiece camera on the 1-meter telescope at Allan I Carswell Observatory. So if you can just see, this is a little bit hazy at the moment, but this is a live eyepiece camera view. So this is how as you would see it from the eyepiece on campus if we were allowed to let people go up and look through the eyepiece at the moment, which unfortunately we're not quite able to do. So you can see that we're on the planet Jupiter, and I'll just actually go over to our star chart here very quickly. And this is our main control for the 1-meter telescope. This is a plane wave interface, so we've got quite a nice little control system. And you can see that the objects in the sky are all situated around on this chart using right ascension and declination. So if you're interested in tracking objects on the sky, this is kind of how we tell where they are. So right now we're pointed down at Jupiter, which is kind of going down in the sky. Mars would be over in the east, so it's on that E side there, rising very bright and very, very red. So when we look through our eyepiece cam, we get to see kind of how Jupiter is looking right now. And, you notice this is kind of on theme. There's a little bit of reddish color here, but the red from Jupiter is quite different than the red from Mars. So I thought, what would be a fun way to start off is maybe some fun and interesting Jupiter facts as well. So we'll go to the most massive planet in our solar system here. Jupiter is actually quite fabulous to look at. It is very striking with these bright bands of different cloud layers. Let me just give a shout out to my crew. Does anyone have a fun Jupiter fact they'd like to share with the audience tonight? All right, Quinton.
Hey, so one interesting thing that I heard about Jupiter recently concerns its clouds, and specifically why they have those bright kind of reddish bands, which should be visible in this image. Yeah, they're a little faint, but you can see several of the darker reddish bands on the light planet. So the sorry, one second.
We always sometimes get audio difficulties in the midst of showing things, but we can see, if you notice this striping here, this is what Quentin was talking about with the bands, and the color red does come through the eyepiece. So this is basically a true color image, which is a little bit unusual in astronomy. How is your audio, Quentin?
I think it's okay now.
Yep, you're all good.
Okay, cool. So Jupiter's bands are due to ammonium and ammonium hydrosulfide clouds, which are actually only a few dozen kilometers thick. Jupiter itself is, of course, very large, around about 142,000 kilometers wide. And I was surprised to learn that the cloud deck, which is visible to us, is only is only a few kilometers thick. The below that level, it's almost exclusively hydrogen and helium in roughly similar proportions to what you'd see in the sun. So I find it interesting that that surface layer of Jupiter, where all of those interesting bands are and all those storms are, is just that. It's just the surface of a much, much larger structure.
Oh, exactly. And I'm so glad you mentioned the abundances of hydrogen and helium, because if Jupiter was a few times larger, 10 so-ish, Jupiter could have been a star if it was only just more massive. It has the right composition. So this is why we call it kind of a gas giant. It's sometimes thought of as a very failed star. So it is a very, very interesting planet. All right, Sunna, I think you have one as well.
Yes, yes. It's something that it's very, very hard to see with ground-based telescopes, is that Jupiter has rings. Like all of the gas giants in our solar system, it has a thin set of rings. So in contrast to Saturn, whose rings are very, very bright and very easy to see, even when looking at it with a small telescope, Jupiter's rings and the rings of the other gas giants are much thinner and they're much darker, making them much more difficult to see. Jupiter's rings were actually only discovered when the Voyager 1 probe, I believe it was, went to Jupiter in 1979 and did a flyby and observed its rings for the first time. And prior to that, we had no clue that Jupiter had rings at all. And I think that's pretty cool, that all of the gas giants, Jupiter included, have these very thin rings surrounding them.
Absolutely. Jupiter is a very, very fun planet. Of course, being the largest, it does have a lot of heft, shall we say. It also has some very interesting moons. I was just playing with the exposure time on the, you might have seen that pop up very quickly. By saturating out Jupiter, we can just start to pick up some of the moons. But we will go back to the features here for the bands, just to show you how that looks for this conversation. Let's see. Quinton, you had another one?
Yeah. So, of course, one of the most famous features that is visible on Jupiter is, of course, the Great Red Spot, which, as we all know, is an immense storm, a storm larger than the Earth itself. It's sort of an analog to a tornado or a hurricane that you'd see on Earth. That's why it has that round shape, is because it consists of wind, which is spinning around as the storm moves around Jupiter. And that storm has been raging for decades. We have been able to image that storm since as long as we've been able to image Jupiter in detail, really. However, it isn't static, and the storm has shrunk significantly over the past 30 or 40 years. So we have images of Jupiter taken in the 1970s, and in those images, the Great Red Spot is significantly larger than it is now. The Great Red Spot used to be large enough that it could fit 3 Earths inside it. It is now only large enough to fit 1, which is still absolutely immense, but it does kind of bear to remember that Jupiter is, like all planets, a dynamic system, and all of the famous features that we have come to associate with it do in fact have an expiration date. So eventually, like any storm on Earth, the Great Red Spot will eventually stop spinning, and that lovely feature of Jupiter will eventually go away.
Yeah, exactly. It's nothing lasts forever, as they say. Well, let's see here. Now we've got Jupiter up, and we've done a couple interesting Jupiter facts. Now, of course, Jupiter isn't the only red planet that we're here to see. So I'm going to just go ahead and hop over back to our Mars facts here, and let the crew take care of moving the telescope. It does take a little bit of time to move the telescope across. And of course, with these instruments, we don't just move the telescope, we also move the dome. And of course, that will involve them going out and, turning some buttons. So let's hop over to some fun Mars Information for tonight, of course, this is very, very close to opposition. We're not technically at opposition today. The actual opposition will be the 13th. But interestingly, a little Mars fun orbit fact, we don't have quite the, the best necessarily the best view, shall we say, on the 13th. It's actually at its best for this whole week, all the way through to, all the way through to about the 15th, 17th or so. All right, so I think we have a couple interesting facts with Kat. You had a little bit of opposition knowledge to pass to us, so I'm going to go ahead and put that up for you. Go ahead, Kat.
Thank you, Dr. Hyde. Okay, so now we'll be talking about just opposition in general, get some, basic know-how out there. So an opposition occurs when the sun and Mars are on either side of the Earth, such that as soon as the sun rises in the east, Mars will set in the west. Since these two events happen at the same time, we dub it opposition, as they directly oppose one another. Normally, opposition occurs once every 15 to 17 years, occurring within a few weeks of Mars's perihelion, or perihelic opposition, as one might say, the point where it is closest to the sun along its elliptical orbit. So some perihelic oppositions bring us closer to Mars than other oppositions. So it can also be noted that the elliptical orbit of Mars has become gradually more elongated over the past few millennia, which brings Mars even closer towards the sun at the perihelion. So what does this mean for future oppositions? Well, Earth and Mars will be closer than ever before. And now,
yes. Oh, yes, of course. So let's go ahead and go to your next one. Can you just, I believe your next interesting point was all the way over on Mars, the Eye of Mars?
No, it was on the Hellas Basin.
Ah, yes. Hellas Basin. Here we go. Yes, that's one.
Yes.
So this is one of the many, many very interesting features that we hope to catch.
Yes, indeed. So a little bit about it. Between the southern border of the Syrtis Major and the southern polar cap lies the Hellas Basin. So this 2,300 kilometer diameter basin is one of the largest impact craters in the solar system. The depression into Mars, measured at approximately 8 kilometers deep, noted as being the lowest point on the surface of the planet, indicated on the picture to the left as per the topology of this area. So the depressions are illustrated in more purple tones, whilst the higher peaks are represented in red. Hellas can sometimes appear bright due to the clouds that form in the basin and was likely formed during early Mars history.
Yes, I love Hellas Basin. It is one of my all-time favorite objects. And this actually, I'll just add a little bit of fun facts to this as well, since we are talking about Hellas Basin here. I'm just going to go ahead and show, if you can see the white circle, that whole region of Hellas Basin, it has kind of a lowest point region. And what it does is that lowest point is at a lower elevation, which means it actually has higher air pressure. And we haven't talked a lot about the air on Mars, but to be fair, there's not a lot there to talk about. It's very, very thin. So one of the things people worry about when they think about astronauts on Mars is, of course, bringing along oxygen tanks and breathing apparatus, because you wouldn't have enough air to breathe, and the air pressure would be so low that actually it would be deadly to humans unless you were down in Hellas Basin, which is down in the middle of this sort of Hellas Planitia area, because the air pressure is actually higher there, and you can kind of approach sort of the regions of sort of the tops of the Himalayas in terms of air pressure. So you could bring oxygen and not die immediately, which is kind of unique in the places that aren't Earthless, as they say. Great spot, and actually not a bad place if you're looking for, a little summer home, if you don't mind it actually being quite cold. Alrighty, so let's go ahead. I think, Sunna, you were up next, and you had a couple interesting parts of Mars that you wanted to talk about as well. Now you had, I think, Valles Marineris, right?
Yes. So we'll just talk a little bit about this and one of the other features on Mars that you can observe. So now that you know a bit more about Mars and its opposition, we'll talk about one of my favorite features on Mars, the Valles Marineris. So the Valles Marineris, which is Latin for the Mariner Valleys and named after the Mariner 9 orbiter credited for its discovery, is a massive canyon formation near Mars's equator. The canyon system is one of the largest canyon systems in the solar system and covers an area on Mars's surface almost the size of the USA. The valleys stretch over 4,000 kilometers long, they're 200 kilometers wide, and about 8 kilometers deep. To compare, the Grand Canyon's maximum depth is about 1.8 kilometers, so these are huge. There are several theories on how it formed, including plate tectonics or volcanic activity during the early days of Mars's formation, which were then followed by landslides and further volcanic activity to widen and deepen the trench. The image on the left of the slide is a mosaic compiled from the Viking 1 orbiter mission and shows just how much of Mars's surface the canyon covers. On the top right is a more detailed image of the Valles Marineris, also taken by Viking 1, and the bottom right image shows a topographic view.
Oh, yeah, that is absolutely lovely. And again, this is one of the most interesting places. Now, you also had, I believe, the region above this, didn't you?
Yes. Yes, so the polar regions of Mars, so they're very, very interesting areas. So starting with the North Pole, the Planium Boreum is home to a permanent water ice cap and a seasonal dry carbon dioxide ice cap, which sits on top of the water ice during Martian winters. The water ice cap can reach up to 3 kilometers in depth at some points. The North Pole also has another canyon, which is more comparable in size to the Grand Canyon, called the Chasma Boreale. The image on the left shows the ice cap and also some dust storms around the Planium Boreum taken by the Mars Global Surveyor. The image on the right is a more detailed image of the North Pole water ice cap. Mars's South Pole, the Planium Australia, also has some interesting features. There's a permanent water and carbon approximately 3 kilometers thick, and recent observations by the European Space Agency's Mars Express orbiter indicate the presence of saltwater lakes under the southern ice cap.
Indeed, and those lakes are very, very interesting ones. And you can, like say, we can't actually see lakes on Mars, but we can see where they ought to be, and that is the polar caps. And there's a little bit of debate as to how many exactly. Is it 3? Is it 4? Is it 5? But these lakes are probably ancient, and if the temperature estimates are correct, they would be what's called supersaturated. So these lakes would be supersaturated with salts because they're liquid, at least that's what the radar tells us, but they're also very, very, very cold. And to be liquid at that temperature for water means something must be different in your density. And what they think is that these lakes might be at basically the maximum saturation of salts that is possible for water, which would make them sort of denser than the Dead Sea, if you have ever heard of that one. That's one on Earth, where it's a body of water that is got so much salt in it that you can just about buoy yourself to the surface. You takes no effort whatsoever to float because the water itself is so much denser. And this water would be much, much denser than that. So the question is really, if it is a lake and if it is this dense, well, gosh, what would that mean for any creatures? Because I don't, think that's a particularly, shall we say, friendly environment for life as we know it. Alrighty, wonderful, wonderful objects on Mars. Now, because this is Mars opposition, let's chit chat a little bit just about what you might be able to see up in the sky tonight. And I'm just going to give a little spoiler, episode here about how to find Mars in the sky. So let me just go back up here. So if you are looking out right now, you will be able to see Mars. It is visible. It's very, very bright. Now, because we've got all kinds of different locations, I can tell you that at least in Toronto, you can see Mars very clearly, even from the city. If you are out at York University, it is a little bit darker and it's a lot easier to see. This really, really shines through. And it's near this constellation of Pisces in the east currently. So as the night continues and it gets later and later, Mars will eventually sort of be more southerly direction, and that will be around, oh gosh, 1 a.m. or so. And then Mars will continue its journey across the sky, and it will actually be setting about the time the sun is rising. And this is not a coincidence because Mars is at opposition. So what does opposition mean? Well, opposition actually means that Mars is opposite in the sky from the sun. So it is setting in the west when the sun is rising in the east, which also means that we get a fabulous view of Mars all night long. So we could, in theory, stay up all night if we wanted to. Not that we're going to. I think we have slated to end at 10. Now, if we were watching Mars go across, you'd be like, okay, well, Mars is on the opposite side from where I am, but what does that really mean? Well, what that really means is that Mars is actually on the opposite side of the sun in our orbits. So how I like to view it is that Mars is kind of on the outside track, and we're two race cars driving around a circuit. So this diagram here shows Earth's orbit and Mars's orbit. And as they go around, we kind of get this point where we're both driving our planets along these tracks and Mars comes past us and we get that closest approach. So that's our closest approach is near opposition, but because the orbits aren't perfectly circular, it's not actually at opposition. So opposition is when the sun and the earth and Mars all line up. The brightest, the physically brightest possible day and the physically closest day are around that time. So it's always a little bit different depending on the geometry of our orbits. Now let's see here. I think we did have one of our crew who wanted to look at was it Sunna slide 15, I think? So we'll go ahead and hop over there. Now, because Mars is so close, we can see a lot more features on Mars. So because we can see more features in more detail, we might have more things that we can make out here from Earth. So this is 15 for Sunna?
Yes, so another feature on Mars. So to the west of the Aurora Sinus is something called the Eye of Mars, which with the central feature being the dark soils like lacus. It is also commonly referred to as the oculus, which is the Latin word for eye, because the light is focused in the surrounding area, closely resembling a pupil. Pictured to the left is a plane on which the soils lacus resides, and to the left is a Hubble captured image of the eye, located to the lower right of this perspective of Mars. As well, the size and shape of the soils lacus varies based on dust storm occurrences, also analogous to the widening and narrowing of one's pupil. The immense Valles Marineris Canyon lies northeast of this feature.
Absolutely lovely. Yes, and the Valles Marineris popping up again. I don't know if we've remembered to say it yet this broadcast, but that is actually bigger than the entire width of Canada. It is absolutely a tremendous, tremendous canyon on a planet that is actually a bit smaller than Earth. And we have, actually we kind of skipped over it a little bit before, but I'll just actually go back here very quickly. We have all kinds of interesting things about Mars that make it a very fun, almost analogy. Mars is not as massive as Earth. Mars is quite a bit smaller. It's about half the size and, something, 0.1 times the mass or so, 0.107, but it's so much smaller than Earth, and it has some of these absolutely gigantic features. So that when we're talking about canyons that are larger than the entirety of the width of Canada on this little planet, we also have the largest mountains. We have gigantic polar caps, and so you really get almost a contrast in scale and sizes. All right, folks, I think we have a little bit of a winner here. I'm going to go ahead and hop over to our live view where Anna and Obada have been busily trying to get us onto Mars. So we're going to go back and steal the camera from them to show you. Speaking of Mars, all right, so as you can see, our crew has managed to point over in the direction of Mars. It is very, very bright. So the first things we're seeing here are a bit of saturation and a bit of blur while our crew tries to focus. So I'm actually going to, I'm actually going to sneak over and put on another camera for you just to see if we can get the, just to see if we can get a little bit of a sharper image. So this telescope, our 1 meter, it actually has multiple cameras we can try. And one of our cameras is a CCD camera. The other one gives us a little bit more realistic, shall we say, colors, the eyepiece camera. So I'm going to just try this while we're live on air, just for the heck of it. What could go wrong? As they say, don't try live demos, but we'll go ahead and try one anyways. Now, let's go ahead and see here. Now I'm in the live camera, so let me just pull this to the side. Oh, I'm not connected. Here we go. Alrighty. Of course, they say never try too many live demos or you will get into trouble. So we are just working on our camera here to get the live image in. But in the meantime, I'm actually going to just do the old-fashioned method and show you an image from our live camera from Monday. And this is what we're trying to pull through for you. This was Monday, October 5th, and it was quite hazy. So we actually should be able to do a little bit better today. Let's see here. And this, I'll just take any guesses. Would any of our crew like to try to guess what this feature might be now that we've talked about a few of them? Or maybe guesses from chat as well? No guesses. All right. Well, let's see here. It rhymes with Syrtis Major. Actually, I think I've got the solution up here. Okay, so we've got different images coming through, and this will be different at different times of the day, different times of the year. So we can actually see various parts of Mars at different times. If we could watch it all night, because Mars rotates and we rotate, it would actually be possible to sort of watch features spinning past. Okay, now let's see here. I think we had a couple more. Kat, you had an interesting Mars fact you wanted to go to. Shall we go to that next?
I suppose we can, yes. So
And can you just remind me which fact did you have again?
It was slide 18.
All right, we're going to go to 18. Oh, Mars fun facts. Yes, this is actually a great one.
Yes, indeed. I know, indeed. So Mars is a really interesting planet, but not only because it could be our future home. So did you know that its red color due to the oxidized iron reminded people of blood, hence it being the namesake of Mars, the Roman god of war? Not only that, but the god's varying temper was brought to mind when they saw the planet's dramatic variance in brightness over time due to its distance from Earth. Mars, like many planets in our solar system, has natural satellites orbiting it. Phobos and Deimos are Mars's two moons, named for the sons of the Roman god Mars's Greek equivalent, Ares. They were found within a span of 7 days by Asaph Hall, Deimos the night after he nearly quit his search. These moons are suspected to have been asteroids captured by Mars's gravity. Both with little mass, small enough to not have a large gravitational force to round off the moons, Phobos is actually falling towards Mars, gradually, of course, and will either break into pieces or collide with its host planet in 50 million years. Once this occurs, Mars may gather the particles and form its own ring, similar to other planets nearby, the most obvious of which we name Saturn. One other interesting fact about Mars is that just less than half of humanity's missions to the red planet have actually been successful. However, they have grown increasingly effective and successful, proving the importance of patience, dedication, and yes, perseverance.
Excellent. Excellent tie through. Yes, perseverance. And I keep forgetting the name of the helicopter. Perseverance is the rover, and the helicopter is Ingenuity. That's what it is. Very, very nice. And that is some great fun facts as well. Now, Quinton, you had another one about, I think, ice, was it? And I'm just going to interrupt our view here for a second to pull the live camera to the side. All right, go ahead, Quinton.
All right. So as you've all seen, Mars has many interesting features, and some of them include the vast valleys and canyons that we were showing earlier. But those canyons actually indicate that liquid water once ran through them. So despite Mars currently being a dry wasteland, we have significant evidence that Mars had plenty of liquid water that has now been sublimated or frozen under the surface. The most obvious point is the polar ice caps on the poles of Mars. These ice caps are composed of both dry ice and water ice. Some previous missions to Mars were able to detect snow. Yes, snow in the upper regions of the atmosphere. Although it isn't anything like the snow here in Toronto, it is still a very interesting and significant discovery.
Well, yeah, exactly. Yeah.
In addition to all this, ice is easily found in many regions buried under the Martian sand. So this could be very useful to future astronauts who are not going to be carrying their own water supply. There are significant reserves of water on Mars's surface, and we would be able, in theory, to harvest that, ideally to live off of.
Indeed, and actually, the nice thing that people always mention about Mars is that it does have so many resources that we could, in theory, use for various different things. We have, water in theory, we have nitrogen in theory, we know we have lots of carbon dioxide, and with those elements we can make things like fuel for engines. So you start to think that maybe it might not be such a bad place to live, and then you read a bit more about the atmosphere. Now you also had some fun facts from chemistry on Mars.
Yeah, Mars has huge dust storms that can cover the entire planet for several months. A theory as to why this occurs is because airborne dust particles will absorb heat from the sun, which will create pockets of warm air. That warm air will move towards colder regions, and in the process of doing so, generate winds. These winds kick up more dust particles, and the cycle continues. So it is actually possible, and I believe, yes, this image displays it. You can see that all of the surface features of Mars are hidden in that image on the right because there's so much dust in the air that it is blocking the view of the surface itself. Mars's tilt swings wildly over time, unlike Earth's, which stays at an average of 23.5 degrees. The reason is because Mars doesn't have a large enough moon to stabilize it, unlike ours. So Earth's moon is, in fact, a bit of an anomaly because of all of the planets in our solar system, that our moon is the largest in comparison to its host body. So it isn't the largest moon in the solar system. That honor goes to Ganymede, which is a moon of Jupiter. But compared to the Earth, it is the largest in relation to its host body, which is just something else that really sets the Earth apart. Mars currently has no magnetic field. However, there are regions on Mars that have at least 10 times the magnitude of any magnetic field measured on Earth, which may hint at the possibility of an ancient magnetic field. And going back to chemistry, blueberries were recently discovered on Mars. Well, not the blueberries we know, but instead iron-rich spheres found near the landing site of NASA's Opportunity rover. They indicate that Mars was once incredibly wet, flowing with a lot of liquid water. So those iron-rich spheres it's a sort of yet another indication of how much surface water there used to be on Mars. And it's interesting to think what sort of life might have possibly existed in that water. We will need to keep searching Mars's surface for any evidence of fossils.
Absolutely. And of course, there was that meteorite not too long ago discovered in Antarctica, that there was also some talk of possible fossils. So, it's one of those places we really have to just go there and look, I suppose, which, a lot of humans are trying to do at the moment. Okay, so we do have a little bit of an oversaturated Mars, but I'm just going to put it back up for you again. And this is quite bright, so we're just going to try to reduce the intensity here. Our crew is working hard trying to get it up and running. While they try to get that intensity down, as I said, it is brighter than Jupiter and brighter than Sirius at the moment. So it actually is a funny little caveat about astronomy in general, is that bright things are also very hard to see. If it's too bright, you can't look at it quite correctly. For example, the sun is much too bright to look at directly. Please don't ever do that. But the moon is around the same size in the sky to us, and it's so much dimmer that we can easily see all the features. So if we can dim down Mars enough to pull out the features, we should be able to show a bit more of them for you. Okay. Quinton, you wanted to go into a little more detail about the blueberries. So let me just go ahead and put up the material that the blueberries are made of, which is our number 22 here, just for reference for the crew. So the blueberries are made of hematite. And did you want to cover this, Quinton?
Oh, yes, please. I was hoping that I'd get to talk a little bit more about the blueberries because it's really fascinating. So why are these rocks so interesting? It's all about their composition. As Professor Hyde was saying, the so-called blueberries are actually hematite spheres. And hematite is a material that is often formed in a wet and water-rich environment. So if we can understand hematite here on Earth, we might expect that on Mars, water would have been needed in order to make these materials appear. Hematite also has a reddish to black color because of its iron and oxygen. As you might have heard before, Mars gets its overall red color from all the iron in the surface rocks, and that includes hematite. I remember being really surprised when I found out that the reason why Mars is so red is essentially because it's rusty. All of the soil contains iron oxides and other iron compounds like hematite and similar substances.
Oh yeah, exactly. And it's hematite in particular is interesting because of its formation with water. It is often formed in a wet environment, like standing water, and we know that there are hematite spheres that have formed with water here on Earth. And so when those same hematite spheres were found on Mars, a lot of people got very excited. It's there are just so many clear evidences for water on Mars in the past, that it is a well accepted theory at this point. I think, of course, water on Mars right now would not do so well. If you put a glass of water on the surface, it would do something called sublimation, which is where it would go directly from a solid phase into a gas. It would be so cold that it would freeze, and it would instantly then just transpire into a gas, because the pressure and the temperature of Mars on the surface is not enough to sort of allow it to exist in an actual water form. So this is actually, they say Mars rocks. Well, Mars really does rock. It actually is all about rocks at the moment. Different forms of rocks on Mars make up lava, make up hematite, all kinds of different things. And I'll just go ahead and put up this next, with Mars, one of the interesting things about its rocks is that we can trace back a lot of the activity to either sort of volcanic or water-based or some combination thereof. And so you have things like hot water containing salts, possibly being heated by magmas, creating mineral deposits, which we see today as, minerals are kind of a form of rock. There's also sedimentary rocks, which have been deposited from erosion or volcanism and various other things. And of course, there's the igneous, which is basically your lava rocks. So if you've ever been to Hawaii or someplace that has active volcanoes, you will have seen these black, cooled, solidified magma showing up. And the minerals that crystallize really make those, they're incredibly jagged and pointy. Those igneous rocks are very distinctive, shall we say. And then, of course, we also have metamorphic rocks, which were transformed by some sort of combination of heat and pressure. And so all of these different kinds of rocks we are familiar with, we can find on Mars, but generally speaking, the processes are all quite old. So this is things that tended to happen, millions, possibly even billions of years ago. And now, it's just sort of been not doing a lot since then, other than gradually cooling down. But of our different kinds of rocks, there's a few that were pretty famous. I'm just going to go ahead and put up one example of Martian geology with resurfacing, as they say. So if you missed it, this was a quite famous one back in the day. Mars, the face on Mars. So one interesting thing about Mars is that it does have very high winds, and of course erosion happening, as well. And because it has winds and erosion and mountains, things can kind of pop out sometimes. So you might have heard of, Horsehead Bluff, or, Buffalo Hill, or, that one rock that really looks like a face somewhere in your neighborhood. Well, Mars also had a rock that really looked like a face from a certain angle in a certain shadow. And this picture made quite a splash. It actually was featured in one of the science fiction movies. Now, it's been quite quite a while since, and we have developed our camera technology. And of course, NASA went back and they imaged this particular hill in great detail. And it's a very interesting hill, which has a lot of sort of resurfacing. But it's not actually something that we think is an actual face. So it's one of those cases where it just happened to have the exact right combination of light and shadow. So Mars is also a bit different than Earth in some ways. It has sort of cycles in its obliquity of, about 0 and 60 degrees. So its tilt changes. Earth, we have that nice 23.5 degree tilt that just sort of goes around in a very even fashion. So one thing is with Mars, because it has such a difference in its orbit and orbital properties, Mars have, much more, heat in the south surface, or would this affect gully behavior? Would it affect, the motion of water on the planet? And how would this affect the poles, which we already know are water rich, and we were just talking about lakes earlier. So Mars is not really dead or dry. It's just very, very, very different. All right, so our fun Mars extravaganza continues here. And actually, let me just hop over here for just a second. Now we do have a couple questions coming in from chat, which we will try to answer as many of them as we can. So if you do have chat questions, just feel free to chime in. There's a little tiny delay for us, so sometimes it seems like we're taking an extra long time to answer your question. But there's a great one from Mark Sawyer. I'll just call out, can you use neutral density filters on the telescope to reduce the exposure? And actually, that is a great question, because that is exactly the filter that I use. It is a neutral density ND5 filter, because Mars is so bright at the moment. It needs quite a hefty filter. That filter is really what we need to go ahead and look at things like Mars through our CCD camera. Now, the eyepiece camera doesn't quite have that same problem, because it takes exposures in, I believe, milliseconds, and stacks them to kind of form an image as you would see through the eyepiece. Okay. So very, very good. Now we've got a call out from Sunna. You were talking about features on Mars and the volcano, which we haven't really gotten to yet.
Yes. So the Martian volcano, which was mentioned earlier, so it's kind of remarkable how Mars is a pretty small planet, but it has some of the best features, or some of the largest ones in the whole solar system. And one of those is Olympus Mons. So Olympus Mons is an extremely large shield volcano, and it is the tallest mountain in the solar system. Its height from base level is 21 kilometers, making it 2.5 times the height of Mount Everest. It encompasses an area roughly the size of the state of Arizona, and it is easily visible from the Earth. There are several reasons why this volcano is much larger than anything on our planet. The most obvious answer is the lack of gravity, allowing structures to keep growing beyond their collapse height. Another reason is due to the lack of tectonic plates on Mars. The reason volcanoes grow is due to the fact that hot magma is pouring from the inner parts of the planet. On Earth, these plumes move relative to the plates, causing a more scattered mountain formation like the chains of Hawaii. On Mars, these plumes keep spewing magma in the same spot, which allows for volcanoes, like Olympus Mons, to grow so tall and wide. So it turns out, in this case, Mars being much smaller allows it to have a much bigger mountain, and the biggest one in the solar system.
Exactly. That's a wonderful point. Now, Quinton, you said there's a good question about the rovers.
Yes. We have a question from Brian Abdallah. Is the rover still sending pics? So you may remember there was a news article fairly recently from last year. In February of 2019, NASA declared the Opportunity rover mission complete. The rover was unable to, it ran out of power and was unable to recharge its batteries. However, there is a second rover, which is currently operational on Mars, and that is Curiosity. And the Curiosity rover is still operational. It is still sending images. It is still doing research. So the answer is yes, we do still have an active rover presence on the surface of Mars, even if the opportunity is unfortunately no longer able to collect data.
Indeed, and we are very much looking forward to the new missions coming up, 3 of which are on the way to the red planet. And the reason for that is also not an accident. It is in fact opposition. So opposition meaning Mars is closer, meaning the spacecraft that have launched don't have as far to go. So I'll just hop back up to my handy reference up here with showing the orbits. As you could see, if Mars was on the other side of its orbit all the way across, it would take quite a long time for a spacecraft from Earth to travel all the way around and catch up to Mars. But if we wait until Mars is right across next to us, or if we do like NASA and the UAE and China, all 3 launched just a few months ago before we were at opposition. So if you can kind of imagine Earth rolling backwards a little bit in its orbit, and the spacecrafts launch up, and as they travel towards Mars, we all sort of move into this scenario. So they're able to approach Mars with this kind of closest to distance in mind. Now, this is an ideal time to launch a spacecraft. If you've got one and you didn't launch it, you'll probably need to wait a couple years until it's as good again. And as we say, this is the best. This is the best opposition right now for the next, about 15 years. But they do happen on average about every 2 years. You get maybe not as good as this year, but you still get a better than usual sort of scenario. Now, because we've got this, lined up here, if you had astronauts who were going to go to Mars and live on the surface, you would want to take this into account, because if you sent them over, they would probably want to either come back very, very, very quickly, or plan to stay there for a couple of years until it was, in the same configuration again. And this would mean that, you would limit the travel time that, traveling through the empty vacuum of space, very, very dangerous stuff. So you want to limit that as much as you can, get people across quite quickly. So if you were going to Mars, my personal preference is, of course, that we just go and build some cities there, and you could live there, and you could go and, have a nice 2-year vacation and then come back, back when it was all the way around across. So, worth keeping in mind if you're making travel plans or planning to build your own spacecraft at some point. And, of course, don't forget to bring lots and lots of supplies with you. Mars is a very interesting place, but they are definitely lacking in what we say amenities. I don't think Uber Eats is going to be up to any Mars deliveries in the next little while yet. And it is worth noting that as well, Mars, it is very, very good to view right now, and this opposition is the best one in quite a while, but it's not necessarily still super close, right? So I think one thing we sometimes forget about in astronomy is that not everybody is used to the vast distances involved with space travel, and Mars being not just thousands of kilometers away, but actually millions of kilometers away. So this is the closest that Mars is going to get to us for the next 15 years, but it is still 62 million kilometers away. So you want to talk about social distancing? Planets are amazing at this. we are, despite benefiting hugely from this beautiful brightness, it is still millions of kilometers away. And just as a little shout out, if you heard about this in 2003, that was the last time that they had an opposition that was better. So our opposition is pretty good, but in 2003, the opposition was closer than it had been in about 60,000 years. So they say not all planets are created equal, not all oppositions are created equal either. So in 2003 was probably the closest it's been in, eons, 60,000 years. And, we're just a little bit farther than that. So in 2003, it was 55 million kilometers. Now we have 62 million kilometers. So it's a few million kilometers between friends. But if you are looking for a world record beating performance, and you want to beat 2003, you actually need to wait until the year 2287 or 2287, however we end up saying that. So once that occurs, Mars will actually be only 55.6 million kilometers away. So it was still millions and millions of kilometers. Now, a couple interesting chat questions coming in about potatoes on Mars, which is an excellent topic as well. So let me just navigate back here to one of our beautiful pictures of like more Martian soil. So this is some of the regions of Mars that we can see through the telescope pretty easily. And as you say, the red soil really pops out here. Now, growing things on Mars has been studied on Earth for quite a while. And I remember back in the day in Arizona, there was quite a few people studying irradiated soil. And what they did is they took Earth soil and they irradiated it and tried to make it extremely nutrient poor, such that it would match the supposed composition of Martian soil. And what they did then was they grew plants in it. So that's what you do. They tried to figure out what kind of plants they could grow. And they were actually able to grow a variety of plants in this mock Martian soil. Unfortunately, no Martian soil has yet been actually used to grow plants because we have not completed a sample return mission. So this is one of the many reasons why people really want a sample return mission, is because they want to bring back real Mars rocks. Of course, if you're quite brave, you could just go there with your spaceship and hope it works. I'm not sure if they did that in the movie, but Quinton, did you have I believe you had a little bit to add about the soil of Mars?
Yes. Actually, shortly after the movie The Martian came out, some new evidence came out that suggested that the possibility of growing plants on Mars might be even more complicated than we originally thought. Because as it turns out, there is a lot of salt in the Martian soil. And that would severely complicate any attempts to grow plants in that soil. As we all know, salt tends to make it very difficult to grow plants within soil. That's where the whole practice of salting the earth, as the expression goes, came from. So it's actually rather unfortunate that shortly after that movie came out, we first got the evidence of these compounds being in the soil of Mars. But science is want to do that. Science always marches on, and it seems that it's only a matter of time after a certain piece of science fiction comes out that some evidence comes along that demonstrates that it wasn't as realistic as people thought at the time. But that's how it is.
Indeed, as as you say, truth is stranger than fiction. It's also, more surprising because fiction is whatever we can imagine, and the truth sometimes skips that part, and it just is. So they also say, one of the most promising sentences you can hear from any scientist is, "Huh, that's odd." Because that means that something really unusual has happened. So yes, we might have some trouble with salts in the soil, and we were talking earlier as well about the super saturated salty water in these lakes. If the water on Mars is super saturated in general, this would really change how we needed to process it before we could give it to astronauts. So for example, if you're building your dream house in Hallis Basin and you've put up, your cool space house, and you've got a garden, and you've got, water processing plant, and you've got a carbon dioxide processing plant, and you're protected from the atmosphere, and you're protected from radiation, well, you still might be pulling in not just Martian ice, but maybe supersaturated Martian ice that would break your processing plant. So there's all kinds of things to consider there in terms of uh, um, what kind of things can we plan for, and how much do we just need to go there and have a good poke around, maybe dig up some soil. So hopefully that sample return mission works out. And we're able to get some real Mars rocks back, and they can then test them and find out exactly what the conditions really are. Okay, so we're on Mars fun facts, as you know, and I'm just going to take a little minute to remind everybody, thank you for joining us. This is the York University Allan I Carswell Mars event. This is the Mars opposition event. We are all Mars all night. So we have managed to show a few saturated images of Mars. And of course, we have a couple of our live images from Syrtis Major from earlier. Mars is absolutely fabulous to view at the moment, and hopefully we will be able to refocus on Mars for our eyepiece cam so we can show you the color as well as just the image. All right. So of course, we haven't really talked too much about the canals on Mars, although we do have quite a few questions coming in from chat as well. So just as a little shout out, of course, we will try to get as many questions as we can. Let's see. So there's a couple great questions coming in. And I'll just go ahead and hop back to Mars closer to the sun. So great question from Eric about Mars closer to the sun and warmer than it used to be, or hotter. So we know that Mars's history has been very, very patchy. So I'll leave this image up just as a little glimpse through the little smidgens of haze that we have. Now, Mars did used to be wetter and warmer because it had a thicker atmosphere. So early on in the formation of the solar system, we had, of course, Mars and Earth and all of our rocky planets forming. And when those planets formed, they had a lot of heat being released early on in formation. So when you get a large body of rock coming together, it tends to, your denser elements tend to sink. And we know that Earth currently has what's called an active core. So the core of our Earth is liquid. It actually is thought to generate our magnetic field. And it's that liquid rock spinning around that kind of powers the geology of our planet. And Mars would have had that same kind of engine. However, because it was so much smaller, it wasn't able to trap enough heat in its core to really sustain long periods of geological activity. So initially it had volcanoes, it had activity, but it cooled down. It lost heat into space. And because it has such a low mass, it also lost a lot of its atmosphere. So if you lose atmosphere and you lose heat, what happens? Well, what happens is what happened to Mars, is that it's got a very, very thin, tenuous atmosphere. And so although it used to have a lot of geological activity, we don't really see too much of that anymore. We see what used to be there, but we don't see anything huge happening at the moment. Now that said, we're talking about, you know, the obliquity changes. It's possible on long time scales. Maybe there is some sort of periodic activity that we can, you know, observe, but humans will have to go ahead and plan to be around for a little bit longer to try to map all of those out. So per usual, it's a fun story. Now let's see here. All right. Okay, we're just going to try to hop over to our other camera again. Let's see if we can pull that up. Of course, they say never do too many live demos or you're doomed to failure. Well, hopefully not, but we'll see what we can do here. So, all right, what we'll do in the meantime is we're just going to pick our favorite locations on Mars. I think I have Hellas Basin as my favorite location for, you know, my summer house. Anyone else in the crew have a favorite Mars location?
You happen to steal mine. Oh gosh, sorry, Quinton.
Go ahead.
Sorry, you happened to steal mine actually, because I was Hellas Basin was actually the first feature on Mars that I found out about as a kid, other than the polar ice caps, the stuff right on top. Honestly, it really fascinated me to see like how deep that goes, and how massive and how much just of space it takes up on Mars as a whole. And just that in itself is enough to, you know, deem it probably my favorite out of all the features on Mars.
I would have to say that my favorite location on Mars is Cydonia, which is, of course, the so-called face on Mars that you showed earlier. And I think it's really, really fascinating because it's such a great illustration of of an effect called pareidolia. And what that is it is the tendency for the human brain to perceive faces in comparatively very simple visual data. So, for example, a lot of people say that they can see faces in electrical outlets or in the grills of cars. It's not just visual data that can cause this effect. For example, people can hear what sounds like voices in random noise sometimes, and it's because the human brain is so advanced at looking for meaning. It's what we sort of evolved to do, that it's sort of we're almost too good at it. We start to interpret meaning where none actually exists. So all of the older images of Cydonia were taken with lower resolution, and with the shadow of the image, it did look remarkably like a face. Like, even knowing about pareidolia and even knowing about the fact that this isn't really any sort of unnatural feature whatsoever, I still see the face looking at it now. However, since then, we have been able to take higher resolution images with some of the probes that we have sent to Mars. And it is, unfortunately, just a completely normal albedo feature on Mars. It's a ridge with some interesting shading, but a closer look does reveal that it is, in fact, entirely within what we would expect. Still, I find this really fascinating because it's something that you can look at that's on another planet, but it can tell you a lot about ourselves and about our psychology. And I think that that's almost more interesting than learning about than spending time speculating about, is there or is there not actually a face here?
Exactly. It is of course always fun to look for patterns in various things, and to look for different areas of Mars. So one thing I will give a shout out to just Mars in general. We talk a lot about different fun features and areas on Mars, but Mars as a planet has very big. It does nothing small. It's small planet, but it does everything quite large, and it has a dichotomy across its two sort of hemispheres where there's an older surface and a younger surface, and the older surface, of course, it has more cratering. The younger surface, we think, actually used to be kind of um, a lake or some sort of ancient ocean, and that would have been, I'll just see if I can pull up a more friendly Mars map version of it. Let's see here. Where's our best Mars map? Probably this one. So you can kind of see that there's a smooth region in the top and a more cratered region below. And it's thought that there used to be actually a massive lake. And that's kind of what this picture is trying to show, which goes back to some of the questions that we had before. Now let me just see. I do actually have a regular image of Mars coming through. It's just a smidge out of focus still, but I've put it through to our other camera, and we can see some features. So I am going to put this up. All right, folks, this is what happens when you have a little bit of focusing trouble, even on a clear night, but we are getting a couple features coming through on Mars. Now, this is very blurry at the moment, but we can actually see a bit of light coming through. Now, I've switched away from our eyepiece cam because of the trouble that was happening over there. And this is our regular CCD cam. So somebody asked about a neutral density filter before. I'll just go ahead and point to that. We are on neutral density 5. So this is the most neutral density that we can have. Now, anyone want to take a guess as to what this feature might be? It's probably not going to be Syrtis Major, but can you see a face, anyone? Let me see if anyone in chat has any ideas about what faces might be.
You can definitely see some features, but
I guess that'd be the pareidolia popping up again, right? That's the same thing that's responsible for us seeing the man in the moon, what appears to be a face on the lunar surface, or the heart on Pluto's surface as well.
Oh, that's actually an excellent example. There is actually, let me just go back and say, there is one crater on Mars that we didn't talk about. So I should have put this up when we were talking about the red Mars, but this is the happy face crater. So we don't quite have resolution to make out the happy face crater, as you may imagine, but this is the happy face crater on Mars. Let me just put this back through. And this one definitely looks like a face. Let me just check our focus on our CCD. But yes, we were talking, of course, about the red Mars and, the oxidation combining with iron to create rust. Now, it's worth noting that we see this bright red color from Mars when we look in the atmosphere, but it's a bit of an illusion because Mars isn't bright neon red when you get up close to it. It's just red on average. And what happens is that average color sort of becomes, filtered out a little bit. And what we perceive as purely bright neon red, if you're actually on Mars, this is a little bit more of a true color image. It's kind of a dusky, dim sort of, it's red-ish, but I wouldn't say that it's bright neon red or anything. Anyone in chat want to take a little guess as to why Mars has so many craters? And we'll just hop over to chat and see if anyone's got any guesses there. So why Mars has so many craters? It's a question for our chat audience, a little bit of Mars trivia, if you will. Couple folks voting. Excellent. It's close. Oh, excellent answer. Close to the asteroid belt. So asteroids hitting Mars because it has no atmosphere. Okay, so now we're getting all kinds of great answers. So a lot of these are very, very close to what we were looking for. So why does Mars have so many craters? Another way to phrase the question is, why does Mars have so many craters that we can see? So a few people were mentioning that Mars, it does have a little bit of an atmosphere, but it does not have as thick of an atmosphere as Earth. So it would be worse at burning up little tiny particles. So if an asteroid comes in, if it's really, really small, it can burn up in Earth's atmosphere. And that's what we see as things like meteor showers. And those are little tiny sand grains. But if it's bigger than a sand grain, it generally will impact the surface of Earth. And both of those would impact the surface of Mars, but they wouldn't make giant craters. So meteorites don't burn up terribly easy in an atmosphere just in general, unless you've got something like Jupiter or Saturn, but it would make an effect on little tiny particles coming in. And no tectonic action is a great guess because there is no plate tectonics on Mars. So Chalissa is completely correct there. There's no tectonic action on Mars, so we can't get rid of impact craters. And so the fact that we see so many craters on Mars at the moment, it's actually showing us a little bit about the history of the solar system. So it's showing us about how there used to be many more craters in cratering events in the past, because something must have made all these craters, but there's not as many now. So the frequency seems to have decreased. And what happened was the asteroids and things impacting planets like Mars and also the dark side of the moon, they gradually impacted as much as they could. And the things that are left were things like asteroids that settled into the asteroid belt. And actually, it's Jupiter helps protect us a little bit by sort of deflecting some of those asteroids, and every once in a while, the odd comet. And now, Quinton, you have a little something about Phobos and Deimos here as well.
Yes, one of the commenters mentioned or suspected that the reason why Mars has so many visible craters is because it's close to the asteroid belt. And what is interesting is that Phobos and Deimos, Mars's moons, are believed to be from the asteroid belt. They are asteroids that were able to get pulled into a somewhat stable orbit around Mars. And had that not happened, if the asteroid belt didn't exist, it's likely that Mars would not have any moons whatsoever. Venus and Mercury don't have any moons. Earth does have its moon, but as I've already mentioned, it's really an outlier. Earth's moon is extremely unusual. It seems to be the case that it's rather rare for rocky planets to have moons at all. Now, of course, gas giants have a lot of moons. Jupiter and Saturn both have somewhere around 70 to 80 moons. It's actually difficult to keep track of how many moons they have, because every time we take a closer look, we find more. We find moons that enter into the orbit from the asteroid belt, because many of their moons are very small captured asteroids as well. We find moons that get too close and burn up, or get ejected or pass the Roche limit and break up and become part of the ring system. So moons seem to be a dime a dozen for gas giants. Uranus and Neptune both have many, many moons as well, but it's very unusual for rocky planets to have moons. And the fact that Mars is so close to the asteroid belt is likely responsible for the fact that it has any at all.
Indeed, and it is worth noting, we're talking about asteroids and craters. Mars's 2 moons are candidates for creating craters at some point in the future, because they're not actually completely stable. So these 2 moons are captured, as you say, and they're not in a completely stable orbit. So their orbit is degrading, which is one way of saying they're sort of losing a little bit of altitude, and over time they will eventually come in and crash down and create some very, very big and hefty little marks onto the surface, which is not anything for us to worry about if we're thinking of sending astronauts over, but something to something to think about. All right, so we are getting a lovely red color here. So let me just put up the red shiny planet Mars. It is unfortunately just a bit too hazy out. We thought we had perfectly clear skies, but I'm just going to share with you a little bit of our sky situation as well. So this is the live view from the 1-meter telescope here at York University Allan I Carswell Observatory. And as you can see in the background, I've just pulled up the sky navigation chart. Now this is showing us where is Mars, where is Jupiter, where is Saturn, and where they are sort of in the sky with respect to us. As you can see, Mars has risen from the east. It's on its way across the sky, and it'll set in the west and just as the sun is coming up in the east. So it is going to be, in fact, on the opposite side of the sky, and in this case, this really is, it's a physical opposite side. Mars is physically going to be on the opposite side from the sun to the earth. So there's sometimes these things work out very, very nicely. Alrighty. So unfortunately, this is just a bit of haze we're coming through. So what you can see now is actually the fluctuations of the atmosphere. So even though Mars is very, very, very bright, if it's fluctuating too much, what we actually see is images coming in from the atmosphere. So let me see here. Yes, and Quinton, you've actually got an extra, this is actually a good point to mention for Mars's opposition.
Yes, so as we mentioned, Mars is currently very bright. It actually appears brighter in the sky than Jupiter does. Normally, Jupiter is one of the brightest, from the perspective of Earth, one of the brightest objects in space, obviously behind the sun, the moon, and Venus. But Mars is currently outshining Jupiter because it is at opposition. So the reason why Mars appears so bright is partially because it's comparatively quite close to us, because the sun, Earth, and Mars are all in a straight line, or something closely approximating a straight line right now. But the other reason is because the part of Mars that is facing us is also facing the sun. So it's a bit of a similar situation to a full moon. That is another reason why Mars is so bright right now. All of the Martian surface, which we can see, is being directly illuminated by the sunlight. So unlike with the moon, it can be a bit difficult to see how the effects of the sun can result in different changes in brightness. It is possible if you have very under the right conditions and with the right kind of telescope, you can actually see something like a crescent Venus shape if you're looking at Venus at an angle such that the sun is illuminating most of the surface that the sun is illuminating is facing away from you. However, it's a lot more difficult to see under normal conditions because for the most part, to the naked eye, the planets just kind of look like points. But that is the other reason why Mars is so bright right now. It is essentially the Martian equivalent of a full moon.
Indeed, and the Martian full moon is quite full. We are getting a little bit of more contrast on our black and white CCD than our eyepiece cam. So the eyepiece cam is kind of how we describe is this is what you'd be seeing through the eyepiece. You'd be seeing Mars kind of jump around a little bit as the atmosphere fluctuates and hops up and down. If it gets very, very windy out, you can also see a lot of times your objects appear to jump almost like little frogs hopping up and down. Now, our other camera, our non-eyepiece cam, so this is not what you would see with your naked eye. It's got a little bit of a more exposure control as well as that ND5 filter. This we can actually see a bit of a feature coming through. And just if you are watching these, I'm just going to go ahead and give a little plug for the Sky and Telescope Mars Profiler, because it's actually very, very handy in terms of telling what features are up on certain different days and times, if you're interested in tracking Mars. So we talked about, Mars rotates. It has a day actually not too dissimilar to Earth's day. So it wouldn't be terribly hard to adjust. You have maybe a bit of like a daylight savings time sort of lag for a while, but your day-night cycle would not be too bad. Now, and so right now, we actually get a band across Mars, and this is one of what they call the Mare, or the dark areas. Now, Mare on the moon are from lava, and Mare on Mars are from darker dust patches. So in neither case is it seas, unfortunately. And the Syrtis Major region, which if you remember back, I'll actually just put this up in a second. It's moved off to the side. So you get basically one kind of stripy band across Mars happening at the moment. So this is at time 1:21 UT, and today is October 11th. So this is set to universal time. So if I put up my date and time here, sometimes I lose my windows. There we go. If I put my date and time to current, it gives a little tiny update. And so what you can do is actually watch Mars go past here. So if I wanted to see tomorrow, which we will be trying this again with hopefully slightly better seeing conditions, we'll get a bit more features. This is what will be tomorrow. And if I add another day, if I keep adding days, the features on the surface of Mars go by. So while we started looking at Syrtis Major, we end up looking over Mare Serenum, and then we get to Solis Lacus. This area in the middle now is Tharsis, and we can just keep going forward every day, and more and more of the surface becomes revealed to us. So if you were trying to do a giant composition of the entire planet of Mars, watching it over the course of several days would be one way. But if you watch it over the course of one night and actually just watch hour to hour, you will also see these features move. So if we get really good viewing tomorrow or any time between now and the 15th, we'll be able to kind of check at the beginning and the end of the broadcast, sort of hour 1, hour 2, which features are visible. So what we're looking at now, let me just reset to current date and time. Here we have this dark region in it's a band with a little bit of a bump on the side, and we can see what actually we're getting is we're getting a little bit of a dark region, but it's at a little bit of an angle. And so we're seeing part of this Syrtis Major area, but we're seeing it a bit blurred out. Now, if we had a clearer view, now here's where I'll just go ahead and go back. We'll go back to our ICAM view from Monday, and you can see here now we've actually got Syrtis Major a little bit more front and center with actual separation between the different regions. So if I compare these views, you can actually start to see where things might be, and that we are in fact viewing Mars through a telescope, so our perspective is quite a bit skewed here. So if you are interested in tracking Mars's surface position and identifying features, this is actually a very, very nice way to do it. Oh yeah, okay, and there's actually been a great question in the meantime about magnetic fields. So this is one of my favorite topics because I love electricity and magnetism. We wouldn't have light without it. So Mars's magnetic field is really not much to speak of. So Mars has what we call a residual magnetic field, and I'll just put this away. So just if you are interested in tracking these later, this is the Sky and Telescope Mars Profiler. So I did not build this. I am just using it, but it is quite handy in terms of looking at the different features, looking at the different regions, etc. Okay, so now we'll go ahead and look a bit about the surface. So if I'll go over here. So to answer the question about the magnetic field, I'll answer a little bit about Mars's sort of structure. So Mars does not really have a magnetic field anymore, but it used to. And we know that by looking at some of the rocks. So the rocks on Mars's surface, some of them, and especially the very, very old ones in the cratered regions, they have what's called a residual magnetic field, which means that they have aligned themselves with a magnetic field that no longer exists. So at some point in the past, Mars's core used to be more liquid and perhaps used to rotate like Earth's core does. And it had magnetic field generation. So that magnetic field would have protected Mars from harmful radiation from the sun, just like Earth's magnetic field protects us. So the radiation from the sun, when it comes in, if it's very, very high energy radiation, which is the kind that is generally speaking blocked by the magnetic fields, that high energy radiation can excite the particles in your atmosphere and actually cause your upper atmosphere to kind of evaporate off. And so hitting an atmosphere with the full strength of the sun with no magnetic field protecting you would actually cause your atmosphere to escape even faster. So Mars having low gravity was one of the reasons why its atmosphere escaped. Mars not having a magnetic field meant that it actually escaped even faster. So the core can't generate a strong field now. The residual magnetic field isn't enough to really protect it. And the atmosphere that is still there is kind of just, all that could really hang on, shall we say. So it's a little bit of a, a 1-2 punch between the no magnetic field and, of course, the lack of gravity to help hold on to an atmosphere. Really just meant that Mars didn't have much of a chance there. It's just too small. Oh, right. Excellent, excellent question from chat here. All right, and Quinton, you had a quick one about the canals on Mars, I believe.
Sure thing. Of all the planets in the solar system, Mars is perhaps the most famous for speculation about the possibility of having life on it. And all evidence suggests that there is no intelligent life on Mars. There does not seem to be any evidence that there has ever been intelligent life on Mars. It's possible there could have been more simple life on Mars, especially back when its surface had a lot more water. There might even be microbial life on Mars now. That's part of the reason why we really want to get samples back at some point. But as things stand, we are reasonably confident that there are not any civilizations on Mars, but that wasn't always the case. And around the turn of the 20th century, there was a bit of a theory that had got posited that, for better or for worse, ended up being very influential, at least in terms of its effect on pop culture, that there were canals on the surface of Mars. So an astronomer named Giovanni Schiaparelli reported seeing angular, long, straight lines on Mars's surface. And this, he, not really knowing what else to call it, he speculated that these were possibly, he referred to them as canals. Another astronomer, Percival Lowell, sort of ran with this theory and dedicated a lot of his life to popularizing this theory that there were canals on Mars and that they were evidence of some sort of highly advanced civilization that was transporting water from the ice caps at the poles down to the regions near the equator. And over time, more and more evidence began to mount that there really wasn't good reason to believe that the canals existed. One very satisfactory explanation for some astronomers seeing them was an optical illusion. So essentially, if you have any sort of visual field that you're looking through with a telescope that perhaps doesn't provide the crispest image, if you have any sort of object which appears point-like, like say craters or small surface features on Mars's surface, you will see lines connecting those dots. And this goes a long way to explaining why some astronomers swore, like for example, Percival Lowell swore that they could see these lines on Mars's surface, while other astronomers did not report seeing any such sights whatsoever. Of course, now we know that Mars's atmosphere is so thin, it contains very little oxygen. We've been able to image its surface in great detail, especially after the probes and the orbiters that we have sent to Mars. And we know that a lot of the quote unquote evidence that people would point out favoring the existence of intelligent life on Mars, such as the craters or such as Cydonia, really aren't anything special, unfortunately. But that's not to say that this theory wasn't important. It's believed that the idea that there might be craters on Mars inspired the Orson Welles's War of the Worlds, which is one of the most famous and influential works of science fiction ever, and went on to essentially create the alien invasion trope in popular culture. So it kind of goes to show that just because something doesn't necessarily end up bearing out scientifically, that doesn't mean that it isn't necessarily important, or that it doesn't, or that it can't still have an impact. And it's important to acknowledge the history of scientific inquiry to better understand society, and to better understand the popular thought that might have been going around at a certain time period.
Absolutely. And it is always worth remembering that these things do spark the imagination for a reason. And now I'm speaking of imaginations being sparked here. We do have one extra image to show. So one of the other things we do look at sometimes is, ways to stack and combine images. So one of our students, June, has been working on looking at stacking up. Let me just go ahead and put this up here. Stacking up these images, which were a little bit blurry from our eyepiece cam, and actually trying to create a combined image to pop out these features and really make them show up amongst the images. So I'll put this one back because this is where you can see Syrtis Major has a very distinctive blob here, sort of a region extending with a light and dark area. And so especially because it's oriented this way, I'm just going to put up our students' processed image, and you can get an idea of why astronomers like to process these things the way we do. So if I put this up next to it, can you kind of, maybe somebody can tell me if they can see that these two images are in fact very, very similar. They're of the same region, and they're actually oriented the same way. And now we can actually start to see what's really going on with this area. And you can get an idea of what Quinton was saying as well, is if I was watching this night to night after many, many different nights, and you're sort of getting a variety of different images, seeing these shapes change over time, and also, of course, viewing effects, because the air does wobble up and down. You do get the appearance that there's actual motion. So you could imagine maybe, that motion might be associated with some sort of Martian activity, which is, I believe, at least part of the imaginings of early people looking through telescopes. You see all this motion. And some features remain very, very stable, but it seems so active. And a lot of that activity, unfortunately, is in our atmosphere. But the stable features we can bring out very, very well here. So if we're willing to spend a little more time with it, we might even be able to get a few more features to pop out. But I think that was one of them. And this is a little bit of a zoomed out one. So let me see if I can grab that for you. Yes, and this is the same one zoomed out a little. And then this is the Malin cam, which is the eyepiece cam image from before. So I've actually, sorry about this, I've turned it upside down. So this is the other thing you have to watch out for a little bit. If your eyepiece reverses your image, you will sort of view it in the opposite direction that you think you are. So one thing that you will get quite good at if you look at these through telescopes a lot is sort of being able to reorient yourself. So this is the true color from the eyepiece cam, but what was done is actually stack the images several times so that the features are a little bit more distinct, shall we say. Now this one still has a bit of blur around the edge, but all in all, it's very stable. So excellent work, June. Very nice image here. All right. Great show, everybody. Now let's see if we've got any last questions in chat. I know we promised to go to 10, so we'll just go ahead and hop over. If you do have questions in chat, please feel free to ask them there. We are going to try one more time with our live images as well, just to see if we've got a little bit of clearing in the atmosphere. Oh, yes. Okay. So slightly fewer questions, but a little bit of clarification, shall we say, as there were several Welleses involved in the War of the Worlds, Orson Welles and H.G. Wells, both very, very notable for their contributions. And then interesting comment by Chalissa about the Lowell was actually seeing the blood vessels in his eye. That is an interesting theory. And I know that there are some actual eye experts who were looking to kind of try to retroactively diagnose what kind of eye condition he might have had that would have sort of interfered with his vision in a way that the canals and things lines were apparent to him. It is worth noting that his observatory was rather self-funded, and back in the day, he did get, even at his own time, a bit of pushback on his canal theories from his assistants and things like that. So not everybody was saying they could see canals, but it is possible that it might have been a medical condition for him. Alrighty. So let's see what we've got here on our live camera. We'll just see if we can bring up any last images. Let me just see which camera we're pointed at the moment. So we are currently on Malin Cam, but it is still quite poor seeing, unfortunately. I'm just going to see if I can adjust it a little bit here. But our beautiful red color is coming through. And actually, just as a little interesting, I suppose, FAQ, Mars is, when it's like this, it is so bright and so much light is coming through our atmosphere. It's almost better sometimes to view it naked eye, because when you've got a little bit of motion in your atmosphere, you've got a little sparkly action happening up there, the air in our atmosphere moves around and it causes that red bright light from Mars to shift and bump. And what happens is that it actually sort of shifts around to the point where it can really, really glow. So what you get is a very, very glowy red star looking object, but your actual view through the telescope is less fantastic. So tonight might be a really, really good night to go outside and look, as they say, uppity. Now we are getting a little bit of features poking through our eyepiece cam here. As you can see, that central area that we had up before, our Mars profiler, it's a little hard to identify, but this does kind of match with what we saw for Mare, I'm sure I'm saying this wrong, Cimmerium and Tarinum. So say that 10 times fast and you'll win the Astronomer of the Year. So we have our two mares here, as well as Mare Serenum on the side. So that would be on the one side, and then Syrtis Major would be the darker region on the edge. Of course, these are not exactly popping with the seeing tonight. We will try again tomorrow. So if it is clear in Toronto, make sure to stay tuned for live Mars images almost all week, so through Thursday. And again, if you are, having a very, very large meal tomorrow is Canadian Thanksgiving, you can tune in and chill out and see about watching a little bit of Mars action. All right. So as you can see with the Mars shifting up and down here, we are getting a bit of the mare coming through. So those albedo regions are visible now. They were not before, so this is definitely an improvement, but we're not quite at the resolution that we would need to bring out, of course, the polar caps. So those lakes of Martian water remain hidden to us for tonight. All right, let me just go ahead and start wrapping up here and taking last questions. But in the meantime, I would like to give a big shout out to Anna and Obada, who are at the 1 meter telescope right now, making these Jumpy Mars images happen. So live to you from our 1 meter telescope. You are getting a pure, Mars light direct from the outer space through the atmosphere into our telescope and across the internet to you. And let me just give an extra shout out as well. Quinton, Kat, and Sunna, who are all with me here tonight. Everyone chime in and say hello.
Hello.
Hi.
Hello, everybody.
All right, that is our crew for tonight, and we are in fact wrapping up. So we're taking last questions and last call for fun Mars facts. Of course, we could probably do this all night. And I'll just go ahead and say, one of the fun things about Mars we haven't really talked about yet is the clouds. So we talked about Mars doesn't have much of an atmosphere, isn't it sad? But it does have a little bit of an atmosphere, and it can snow. So I'd just like to round off tonight by mentioning and giving a little shout out to the very unappreciated atmosphere of Mars. It's not just dust storms. It does actually have carbon dioxide ice that rains down onto the poles in the winter, and it has cloud structure. So one thing we actually have to worry about when we go to observe Mars, if there's no dust storms, we might still get clouds, and these clouds can go in across Mars's atmosphere. So you can see here on the left an image of a very cloudy time of year on Mars. There's actually clouds in the atmosphere, which are partially obscuring both polar caps. Syrtis Major is one area that often gets cloud cover. You can get a lot of different clouds forming. Of course, there's some really good, if you've got it, I actually didn't preload one, but you can get some great images of clouds forming above, of course, Olympus Mons as well, the largest mountain in the solar system. And these clouds, travel around. There was actually, if you've heard, there was a persistent white cloud in the southern hemisphere that kept appearing for quite a while, and it's actually still a little bit of a mystery. So we don't understand everything about Mars's atmosphere, thin and insubstantial as it is. It does still have sort of the properties of atmospheres as we know them. It still has clouds, it still has snow of a sort, and it still has a bit of activity. So it appears to be somewhat seasonal. There are cloudier seasons and less cloudier seasons, but it also appears that it's, it just like Earth can have weather. So even if we had a perfectly clear day here on Earth, there might be clouds on Mars blocking our view as well. So, it's an interesting place, this planet. All right, folks, we are just taking last questions, and it looks like our last question is a thumbs up from Lyle. So I will go ahead and take it. And we'll wrap up here shortly, but we're just going to go ahead and traverse down our planet Mars all the way to our thank you slide. So I did forget to edit this, so we will not be around for an extra 20 minutes afterwards. Apologies for that. This is a little bit left over from our TeleTube days. We usually stick around 20 to 30 minutes to answer questions, but because we've been doing questions inside the presentation, we will in fact be wrapping it up here very, very shortly. So if you have last questions that we didn't get to, please put them in the comments to the video, or of course, you can email us at observe@yorku.ca. So thank you everyone very, very much for joining. And I am going to go ahead and wrap us off here tonight with a little bit of an outro and a reminder that this is actually a little bit of a spin-off from our regular TeleTube program. So if you like this show and you want to see more about other objects, make sure to tune in on Wednesday nights from 7:30 to 8:30 p.m. Every week, we run a TeleTube show here on the Allan I Carswell Observatory TeleTube YouTube channel. So this is the end of our presentation for our special Mars 2020 TeleTube broadcast. We will be back tomorrow, of course, weather allowing. These broadcasts are presented by Astronomy and Astrophysics the Astronomy and Astrophysics Department, I should say, located at York University. Our students, faculty, alumni, and friends are all involved to help make this program happen. Of course, tonight we had special help from Anna and Obada observing, as well as Sunna, Kat, and Quinton, and myself here presenting tonight. Thank you for joining us on this very exciting occasion for Mars Opposition 2020. If you have other questions or you just like to connect with us, you can find us on Twitter and Instagram with the handle @York Observatory and on Facebook at Allan I Carswell Observatory. All of our programs are free, but if you would like to make a donation, please see our website at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a great night, everyone.